So in this video, we're going to do inner differentiation by substitution. So we're going to evaluate the indefinite integral. So you start off with the antiderivative of quantity, x squared minus sine x, times dx. So now, when you do this, this is an indefinite integral because it has no boundaries. It's not being integrated anywhere. So you're going to need a c. So the antiderivative of x squared is x to the third divided by 3. The antiderivative of negative sine x is positive cosine of x plus c. If you're never sure if you did these correctly, do the derivative of these. The derivative of 3x, or x to the third, is going to, over 3 is going to be 3x squared over 3, which is just going to be x squared. Check. The derivative of cosine of x is negative sine x. And the derivative of c is just 0. So that one's correct. So now we're going to do the next one. If you have this written as 1 over x squared dx, you have to realize it is the same exact thing as x to the negative 2 dx. So when you do the antiderivative of this, you're going to add 1. So you're going to get x to the negative 2 plus 1, which is going to equal negative 1 divided by negative 1 plus c. So another way of writing this is negative 1 over x plus c, because this becomes negative 1 power, x to the negative 2 plus 1, which means it goes down to the denominator. Okay, so now we're going to verify antiderivatives. So I'm going to put a little line over here so we can tell where we're verifying. So if you start off with the integral of the ln of u du, the antiderivative is going to be u ln of u minus u plus c. I would write this down because these are the ones, something like this is something that you're going to forget. It's something that you don't use very often. So now, we're going to check this. The way that you check this is you're going to do d du of big F of x, which is basically the function that you have above. So now the derivative of u, this is going to be, let me write this down. Let f equal u, so f prime is going to equal 1. Let g equal ln of u, so g prime is going to equal 1 over u times 1, which is just going to be 1 over u. So when you do this, it's gf prime plus fg prime. That's for this part over here. Okay, minus 1 plus 0, because we know derivative of u is negative 1, and derivative of c is 0. So now you're going to plug in g is ln of u times f prime, which is 1, plus f is u, g prime is 1 over u, minus 1. So now u divided by u is 1. So now we're going to get ln of u plus 1 minus 1, which is just ln of u, which is check what we had originally up here. Okay, please give me a second while I try to clear this canvas. Okay, so another example is going to be the antiderivative of 1 over root 1 minus u squared. We're going to verify. This is going to equal the inverse of sine plus c. Oh, and I need a u here, otherwise it's not going to work. So now, the derivative of this, I'm just writing it down, needs to equal what we have over there. So now whenever you have an inverse, it's going to be 1 over 1 minus u squared times the derivative of u, which is 1, plus c. So this happened to work. Okay, now we're going to pay attention to the differential. So now I'm going to write down a little bit of information. So let f of x equal x to the third plus 1, and u equal x squared. Find each of the following. Antiderivatives in terms of x. This is a very important concept. So now, if you start off with f of x dx, this is pretty much straightforward. So if you take x and you plug it in, you're going to get x to the third plus 1, the quantity of it, dx. So when you take the antiderivative, it's going to be x to the fourth over 4 plus x plus c. Now, one thing that I want to point out is this and this need to match up. If they don't, you have to get them to match up one way or another. So the second example is f of u du. So you're going to take u and you're going to plug it into this function. So when you take u and you plug it into this function, you're now going to get u cubed plus 1. I did my work over here. So now I have u cubed plus 1 du. The variables match up, so it's not an issue. So the antiderivative of u to the third is u to the fourth over 4 plus u plus c. Now plug in your x squared. So now you're going to get x to the eighth over 4 plus x squared plus c. Now, the last one that we're going to do is f of u dx. Now, if you look over here, your stuff evidently doesn't match up. So you're still going to plug into u, and now you're going to get u to the third plus 1 in terms of dx. Now they need to match up before you do this. So now you could plug in, now you're going to get x to the sixth plus 1 dx. And now the antiderivative of this is going to be x to the seventh over 7 plus x plus c. Okay, I hope this video helped. In the next video, we're going to do u substitution.